There, Mr. Leon Kauma here. So, this is week 2 of our March lessons, and this week I'm going to teach you indices. That's the topic, indices. That's a plural singular index, yeah? So it's a paper 1 topic, and I'm sure you're going to get to learn a lot, yeah? So come with me. So, indices, in the notation 2 to the power 3. 3 is called the power or index. And 2 is the base. So this 2 is the base. This 3 is the power or index. When you go to university, they will say the exponential. Yeah? So that's the brief introduction. Let's look at 0 and negative indices. So a base to the power 0 is equals to 1. Any base to the power 0 is equals to 1. 1 million to the power 0 is 1. Anything to the power 0. X to the power 0 is equals to 1. Then 2. Turn a negative index into a positive by introducing a 1, a fraction. Let me show you this. Here are examples. So examples, evaluate. We have 2 to the power 0. 2 to the power 0, I said any base to the power 0 is 1. So you're going to write 1 here. So that's your answer. Simple as that. To the power 1, anything to the power 0 is 1. We have this. 1 over 2 in brackets with power 3. So evaluate means we find our answer. So we have 1, this 3, put it here. We are breaking brackets now. This 3 comes here. So here we have 1 to the power. This is not 1 times 3. It's 1 times 1 times 1, which gives you 1. This is 2 to the power 3. It is 2 times 2 times 2, not 2 times 3. It's 2 times 2 times 2. This will give you 1 to the 1 over 8. That's your final answer. Yeah. Let's look at this. We have negative 2 in brackets to the power 3. The base is a negative, so it is fine. Unless your power was a negative, you could have been worried. So here you have negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. Times 2. So your final answer gives you negative 8. Simple as that. Now, question 4. This is the big deal now here. This is what ECZ loves. So 1 over 2 in brackets with power negative 2. So this is a fraction. You always want to have a positive power here. So what you do with the fraction, you reciprocate. What this means is that this 2 goes on top, the 1 comes down. So you have 2 over 1, then you have 2. You have seen once you reciprocate, the negative turns into a positive. We proceed, so we have 2 to the power 2 over 1 to the power 2. So this will give us 4 over 1. Final answer is 4. Yeah, come with me to the 5th example. So we have we have 4 to the power negative 2. This is not a fraction, and I said it's wrong to have a negative power. So what you do with a whole number like this, you introduce a 1. So 1 over, you have 4, then you have 2. So once you introduce this 1, meaning this negative 2 becomes a positive. So you have 1 over 4 to the power 2 becomes 16, yeah? So let's move on to other things now. We're now looking at law of indices. The laws of indices. We only have two laws here. So the first one is the multiplication one. So multiplication. So with multiplication, you add the powers. If you're multiplying indices, you always add the powers. Then to division, you subtract the powers. So come with me here. So examples, evaluate 3 times 3 to the power 2. So this will give you, this is multiplication. So you're adding the powers. There's an invisible one here. So you will get 1. Because they are the same, you just pick 1. So you have 1 plus 2. There's 1 here plus 2. It's multiplication, you add the powers. So this will give you 3 to the power 3. This is not 3 times 3. This means 3 times 3 times 3, which gives you 27. So that's your answer. Yeah? So now we go on to B. So we have multiplication, and they are the same, so you pick 1. So you're going to pick 1, then you have 2 plus 2. So this is 2, 2 plus 2, 4. So this is 2 times 2 times 2 times 2, which gives you 16. Yeah. We move on to C. Very easy, isn't it? C we are dividing. So we are going to pick one to be 4, then to be 3 minus 2, which gives you 4 to the power 1. So 4 to the power 1 is 4. Simple as that. So make sure, ask yourself, am I dividing here or am I subtracting? We have our example 4, D. We have 5 to the power 8, divide 5 to the power 9. So you see, we have the same base. So we pick one base. Then we have 8 minus 9. So this gives you 5. 8 minus 9 gives you negative 1. And I said, if you have a negative, you introduce a 1 to make it positive. So that's your answer, 1 over 5. Because like this is wrong. Never have a negative power. So introduce a 1. It's a whole number. A fraction, reciprocate. Yeah? Let's now move on to fractional indices. So we're now looking at fractional indices. So in 4 to the power half, and this is a power, 2 stands for a root. So this 2 stands for a root. This one stands for a power. You get that with my examples. So examples, we have evaluate 9 to the power half. This is what it means. So this half stands for root, stands for a square root because it's 2, so square root. So you're going to have your 9. Since 2 stands for a square root, you're going to have your square root here. You open brackets and close them. Have you seen this one? I'll put it here. Yeah? Makes sense? Cool. So now, what's the root of 9? Root means, square root means what number if you multiply it by itself 2 times will give you 9. Simple. 3. Because 3 times 3 is 9. I have this one. So this will give me 3. Simple as that. I've evaluated. Then we have B. 16 to the power 1 over 4. As I said, this number always stands for a root. So this is 4, meaning we want to find the 4th root. So this is what you're going to write. So you have your 16. Then you're going to have your 4 here. So if it's 4, you show. If it's square root, you just don't show. Then you have your 1 here. Even if it was 2, 3, you put. But here we're using ones. So this is what we have. The question is this. What number if I multiply it 4 times by itself, it will give me 16. That will give me 2. So 2 times 2 times 2 times 2 is 16. Then I have this one. So my final answer is 2. Simple as that. I have this 27. Then we have negative 1 over 3. As I said, we don't need the negative power. What I do, I introduce a 1. So 1 over 27, 1 over 3. So once I introduce a 1, the negative disappears. So this is what we have. We have 1 over, this is 3, means cube root. So cube root, cube 3, 27. And then you see this one, it's this one here. So you have 1 over, cube root means what number if you multiply it by itself 3 times. 3 times it will give you 27. That's 3. Then we have your 1 here. So final answer is 1 over 3. Yeah? Let's look at the last thing, equations involving indices. We're now looking at equations involving indices. Equations involving indices. So equations involving indices are solved by raising both sides of the equation to the reciprocal of the power of a. Yes? So let me explain. I'm sure you're going to get it with explanation. Come with me here. So examples. Evaluate x to the power 3 is equals to 8. So in simple terms, solve for x. What is your x here? So this is what you do. This is about reciprocating. So you have x to the power 3. What's the reciprocal of 3? It's 1 over 3. So a reciprocal of a whole number, you introduce a 1. So you have 8 here. This side, you're going to raise it to the reciprocal you found. So which is 1 over 3. So this will cancel that. You just have your x here. And I said, this 3 stands for what? Cube root. So you're going to have your 8 root here. This is what the examiner wants, show your working like that. So you have x is equals to what number if you multiply it by itself 3 times gives you 8 is 2. So your answer is 2. This can even be proven if you put 2 here, 2 to the power 3 is 8. But you need to show your working, yeah? Let's come here. I want you to get it. You have x, then 1 over 3 is equals to negative 2. This is what you do. You raise it to the reciprocal. So what's the reciprocal of 1 over 3 is 3. Here, let me explain about reciprocating. If I have 1 over 3, my reciprocal is 3. If I have 3, my reciprocal is 1 over 3. So whole number introduce a 1. Yeah? This in simple terms like this. Reciprocating means this that's on the bottom comes up. This that is up comes down. So this in simple terms is this. This is 3 over 1. 1 into 3 is 3. This is what you see here. Yeah? So if it's 4 over 5, this 5 goes up, which is 5. This 4 goes down, it's 4. Simple as this. This is about reciprocating. Yeah? Now that you're with me, so you have negative 2. I said we put the reciprocal here, which is 3. So this will cancel with that. So x is equals to negative 2 to the power 3. We found this. So this is negative 8. Yeah? Simple as that. Let's come here. So we have x, you have negative 2 over 3. It's equals to 25. You want to find your x here. And you have seen such questions. You just reciprocate. Negative 2 over 3. Here to be negative 3 over 2. Then 25. So this cancels that cancels that cancels that. You have your x here. We put our negative 3 over 2. Remember, you put your reciprocal. So this will be 2. Now, I said we don't need a negative. How do you remove a negative? Introduce a 1. So this is 1 over 25, 3 over 2. So x is equals to 1 over 25 here. This 2 stands for root. So you're going to put your root here. Square root, you don't put 2. Just having this is enough to show it's a 2. Then we have a 3 here. This 2 is for a root. This 3 is a power. So x is equals to 1 over, what's the square root of 25 is 5 to the power 3. So final answer is 1 over 125. 5 times 5 times 5 is 125. Yeah? Come, if you're not clear, pause please. We have this 2x, 2 to the power x is equals to 1 over 8. I've seen this in an exam question. They want you to find x. Simple. So you have 2x is equals to, the question is, why did they have a 1 here? The simple logic is that this 1 was introduced because this 8 is a negative. So we're going to make it a negative like that. You see? So why? Because they have to be on the same level. Once you do this, you change the bigger number, or the bigger base into the smaller base. So you have 2x here, 2 to the power x. This 8, how many times you do multiply? What number? You multiply it 3 times, it gives you 8. It is 2. How many times? It's 3. But check, there's a negative here, so you're going to put your negative. The answer is even shouting at you. So these are the same, you cancel them. Your answer is x is equals to negative 3. So x equals to negative 3. Yeah, 2 steps. Change this into a negative, change the bigger base into the smaller base, cancel them, you have your answers here. Yeah? Let's look at the last example. So please, where you're not clear, pause the video and go through. So 9 to the power x is equals to 3. So what you do here, you change this 9 into the smaller base. So to be 3 to the power 2x is equals to 3. Yeah? So now this is 2x is equals, because these are the same, you cancel. There's a power 1 here, so over, this is 1 here. We need to find x, so over 2 over 2. Cancel. X is equals to 1 over 2. So yeah. So that is it about indices. As usual, you have your assignment, you have your pamphlet, you have your quiz. Yeah. Happy solving. I believe in you.